Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 9, Congruency in Triangles, Exercise 9A. First of all, let's understand some terms related to the triangle. Median. The median joins the vertex to the midpoint of the opposite side. That means BD is equal to DC. That is why AD is called the median. Note, it is not perpendicular nor is it an angle bisector. Now, the point where all the medians meet, all three medians meet, is called centroid of the triangle. Next, altitude. It's also called the height from the vertex to the base and a perpendicular. This is the height of the triangle. Even this can be considered as a height or altitude of a triangle from the vertex to the opposite side and a perpendicular. Note, here E is not the midpoint. And the point where all three altitudes meet is called orthocenter. Now let's study what is the meaning of congruent triangles. When two triangles are congruent, it means if I cut this triangle and keep it on top of it, then the margins will match exactly because the corresponding sides are equal as well as the angles are equal. That is, all three angles, corresponding angles are equal. Angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. But when we write congruency, this correspondence should be maintained. I cannot write this as triangle ABC is congruent to triangle AFD. That will be wrong. Because angle A is equal to angle D here. Angle B is equal to angle E. And angle C is equal to angle F. Also, side AB is equal to side DE. BC is equal to EF. And side AC is equal to side DF. So the naming of the triangle in B should be in such a way that the correspondence is maintained. Now there are 5 tests to prove two triangles congruent. First, the Sas test. If in two triangles, a side is equal to side, another side is equal to the other side, and the angle between the two sides are also equal, then we can say that the two triangles are congruent, and it follows that the third side is also equal and the remaining corresponding angles are also equal by CPCT, that is, corresponding parts of congruent triangles. Now understand that if this angle which was equal was not between the two sides, but let's say this angle was equal to this angle, then which test is this? So I'm saying side equal to side, side equal to side, and angle equal to angle. Not this one, okay? So by which test are they congruent? ASS. So which test is this? Well, they are not congruent. There is no such test. There is no AS test. There is only SAS test. If the angle is not between the two sides, we cannot prove them congruent. No. The next test is the ASA test, where angle is equal to angle, angle is equal to angle, and the side between the two angles is equal. So then we can say that these two triangles are congruent. And it follows that the remaining corresponding sides and the remaining corresponding angle will also be equal by CPCT. Now the third test is the AAS test, where angle is equal to angle, angle is equal to angle, and any side, not the side between the two, but any other side is equal. Then too we can say that these two triangles are congruent by AAS test. The fourth test is the SSS test. As you can guess, if side equal to side and side equal to side and the third side is also equal, the two triangles are definitely congruent, and it follows that the angle will also be equal by CPCT. Look at these two triangles. Now side equal to side, side equal to side, and side equal to side. So can you tell me which angles are correspondingly equal? Well, if this is PQR, be very careful about naming the other triangle. This should be PQ is equal to LN. PQR. So one line and second line. So one line and second line. So NLM. NLM. This is the right naming. This is important because now we can say which angles are equal. Angle P will be equal to angle N. So P is equal to N here. Q is equal to L. So angle Q is equal to angle L. And of course R will be equal to M angle. So we should be very careful to find the corresponding angles which are equal. And of course, if there are multiple triangles in a sum, we should use the three-letter naming of the angle, angle PQR or angle QRP. And finally, we have the RHS test. R means right angle. So this is right angle. H is hypotenuse, and any one side are equal. So this looks like angle, side, angle, the AS test, but this is not an AS test. There's no such AS test. We have an RHS test that is applicable only for right angled triangles. So right angle, hypotenuse, and any one side, if they are equal, then the two triangles are congruent. That doesn't mean that if two triangles are right angled, they can be congruent only by RHS test. For example, in these two triangles, what if the hypotenuse are not equal? What if this side is equal to this side? Then this is the usual SAS test of congruency. Now in the exercise, question 1 is cancelled because it's very easy. But if you want to try it, you can. Mark the second sum as IMP and also the 12th sum as IMP. But students, in question 1, only ABCD is cancelled. The echo 1 is for homework. So we are starting with question 2, which is an IMP sum. In this diagram, the information is given. So let's start proving. So here, it's given that O is the center of the circle and P is the midpoint. That means AP is equal to PB. We have to prove that this is a perpendicular. We have to prove this. So what we'll do is we'll join OA and OB. Drawing diagrams is compulsory for each sum, but you can do it freehand with pen or pencil, your choice. Now we'll prove these two triangles congruent. What is the given information? That this side is equal to this side. Also this side is the common side, so that's equal. And this angle is equal to this angle 90 degrees. No, that's not given. That we have to prove. So what is given then? Well, I can say that this side is equal to this side radius of the same circle. So these two triangles are congruent by SSS test. SSS. Now when two triangles are congruent, then their corresponding angles are also equal. So that means this angle will be equal to this angle. Let's assume both of them are x and x. So by linear pair, angle OPA plus angle OPB is equal to 180 degrees. That means x plus x is 180 degrees. So x is 90. Hence we have proved that OP is perpendicular to AB. The statements have to be perfectly written, exactly how I have, with reasons, no shortcuts. I will send pics of all these statements so you can use that for solving. Right now, I just have to explain the sums with the help of diagrams. Now in the fourth sum, this is the information given. The diagram wasn't given, so we should be careful that we read the question carefully, twice if required, and draw the correct diagram. So what is given is that D is a midpoint here, and even AD is extended in such a way that AD is equal to DE. And first of all, they've asked us to prove that these two triangles are congruent. That's what they've asked us to prove. So write Roman number 1. Don't forget sub-question numbers. So how do we prove them? That's so easy. This side is equal to this side and this side is equal to this side. And vertically opposite angles are also equal. Vertically opposite angles. So these two triangles are congruent. And whenever two triangles are congruent, the corresponding angles are also congruent, as well as the corresponding sides are congruent. So Roman number 2 was to prove that this is equal to this. That is proved by CPCT. And in Roman number 3, they want us to prove that this is parallel to this. Well, how about we say that this angle is equal to this angle by CPCT. And whenever alternate angles are equal, it's forming a Z, right? And this is a transversal. Whenever alternate angles are equal, then the two lines are parallel, hence proved by the alternate angles test. You see, we have, if these two lines are parallel, then we have a few equal angles here. If they are parallel, I can say that this angle is equal to this angle, corresponding angles. I can say that this angle is equal to this angle, alternate angles. And I can also say that this angle plus this angle is supplementary 180 if they are parallel, only then. Reason? They are co-interior angles or allied angles. So these are properties of parallel lines which are very useful in many geometry chapters. So solution. I'll be sending pics of these. Now the sixth sum. The perpendicular bisectors of the sides of a triangle meet at I. Here. These are the perpendicular as well as the bisectors. That is, they are 90 degrees as well as this is the midpoint of this and so on. Now, if I join I and A, it is not necessary that AID should be a straight line. Not at all. Only if this was an isosceles triangle or especially an equilateral triangle, then definitely it would have been a straight line. Anyway, in this sum, it's not important for it to be a straight line. Well, dash line is not compulsory. You can draw a solid line as well. Now we have to prove that AI is equal to BI is equal to CI. To prove AI is equal to BI, let's prove these two triangles congruent. How will we do that? Well, I've got 90-90. That's good. I've got BF is equal to FA given. And I've got FI equal to FI, common side. So by which test are they congruent? SAS, SAS. And by CPCT, AI is equal to BI. Similarly, we can prove that BI is equal to CI by proving these two triangles congruent. And we can prove CI is equal to AI by proving these two triangles congruent. So effectively we can say that AI is equal to BI is equal to CI, which is what they wanted us to prove, and that's the solution. Next, the eighth sum. This is the question. Now, in the question, what is given is that AP is an angle bisector. That means this angle is equal to this angle. Also, there is a point M, and we have to prove that MN is equal to ML. Please read the question very carefully before solving the sum. Don't just start solving without reading the question. That is not the way to do geometry. Train yourself to do geometry perfectly, then you will become an expert in it. Follow my method. No shortcut. We have to prove they are equal. They are not, it is not given that they are equal. We have to prove it. So please write it, to prove Mn is equal to Ml, because that is not directly mentioned in the question. They have just said that prove that the perpendiculars are equal. These letters N and L I have written. So whenever something is not given, we have to write that given. So clearly we'll have to prove these two triangles congruent. I got angle and angle, I got angle and angle, and I got this common side in between. So which test is this? I guess ASA? No, it is not ASA, it's AAS. It would be ASA if the side was between the two angles. So be careful about deciding the test. So by AAS test, these two triangles are congruent. So by CPCT, this is equal to this. Next, the ninth sum. Read the question very carefully. Let me explain this. Now, it's a parallelogram. That means this side is parallel to this side, and of course they are equal. That is true for AD and BC also, but that's not relevant for this sum. It's also given that E is the midpoint here of BC. First, they've asked us to prove these two triangles congruent. So I got side equal to side. I got angle equal to angle, vertically opposite angle. And also this angle is equal to this angle, alternate angles, because this DC is parallel to AL or BL. So which test is this? ASA test. We could have said that this angle equal to this angle as well. So these two triangles are congruent. This means that this side is equal to this side. CPCT. But this side is equal to this side, opposite sides of a parallelogram. That means this AB is equal to BL. So Roman number 2 proved. Next, Roman number 3. AL entirely is nothing but AB plus BL. But AB is equal to DC and BL is also equal to DC. So I can say that AL is double of DC. So that's Roman number 3. And these are the steps. You can pause this video and solve it, or you can use the pics. But please write exactly the way I have. In triangle this and this, angle DCE is equal to angle LBE. And while writing, keep looking at the diagram. DCE, okay. LBE, yes, they are equal. Reason, alternate angles, comma, DC parallel to BL. DC parallel to BL, yes. Understand the reasoning and the logic behind each statement and each reason. Then your concepts will become so clear that all the geometry chapters of the future which build on this concept will become easy. Many people have phobia of math simply because they don't have the patience to try to understand the concept behind each step. Invest your time and energy in understanding and then see how easy and scoring math actually is. Next, angle DEC is equal to angle BEL, vertically opposite angle. Okay. Yeah, you can do shortcut here. It's allowed. Only here. Next, EC is equal to BE. Correct, given. So, the two triangles are congruent. By which test? You have to write that. ASA test. So, BL is equal to DC by CPCT, corresponding parts of congruent triangles. But AB is equal to DC, reason opposite sides of a parallelogram. Yeah, that's how we write it. That means AB is equal to BL. And Roman number 3, AL is equal to AB plus BL. That's obvious. So you can write dot dot dot. Common sense. No need to write that. But this is equal to DC and this is also DC. So I can say AL is actually twice DC. Sum is over. This chapter is so easy. 12th sum is IMP. That doesn't mean it's difficult. It's very easy. The sum is that in this triangle, it's an isosceles triangle, AB is given as equal to AC. There is an altitude AD. That means it's perpendicular. Doesn't mean it's a bisector. In fact, we have to prove that it's a bisector. That means we have to prove D is a midpoint of BC. We have to prove AD as the median. And that is always true. In an isosceles triangle, the altitude to the base is also the median. But let's prove it. Here the given is given, so no need to write the given. What I mean is, in the question they have mentioned in triangle ABC, AB is equal to AC and all that. So no need to copy this. But imagine if the question was, in a triangle, isosceles triangle, prove that the altitude is also the median. No letters are given. So we'll have to write the letters. We have to draw our own diagram. In that case, we will write given in triangle ABC, AB is equal to AC, AD is the altitude. To prove that AD is the median, we'll have to write all that because it is not given in the question. But here, fortunately, they have. Otherwise, writing this is compulsory. This carries 1 mark weightage. I mean, if you don't write it, you will lose 1 mark. Don't think that if you just write this much, you'll get 1 mark. So, obviously, we'll prove these two triangles congruent. This seems to be Rhs test. Let's see hypotenuse, hypotenuse, side, side, right angle, right angle. So, Rhs test, congruent. That means this side is equal to this side. That means D is a midpoint. Hence, AD is the median. Done. And now 15th sum. Even this sum is so easy. I mean, why do you feel geometry is difficult? Okay, some sums may be very long. I mean, thrice the size of this sum. Let's say. Yeah, we will encounter such sums in the next exercise. But still, just break it down into smaller parts and use logic. If this is difficult, then what is easy? Sleeping whole day. Two triangles are given. We have to prove AB is equal to FE. Yes, it is given they are parallel, but we have to prove them equal. Obviously, it will be CPCT. Clearly, we have to prove them congruent. Come on, you tell me, what test will you use? Oh yeah, I can't hear you. Anyway, this angle is equal to this angle. It's given. Side is equal to side. That is also given. I need one more thing. Well, this angle is equal to this angle. Alternate angles. They are parallel sides, right? So, which test is this? AAS test. And hence proved that AB is equal to FE. But how do I prove that BD is equal to CF? I can say that BC is equal to DF. Then what? Come on, pause the sum and think on your own. Don't watch ahead. Use your own brain. Do you want it to get rusted? Your brain? Or you want ready-made solutions for everything? Well, I said BC is equal to DF CP CT. But if you notice, BC is nothing but BD plus DC. And DF is nothing but DC plus CF. So write it like that. DC, DC, cut from both the sides. So what is left? BD is equal to CF. It's so easy. Did you get it? Come on, pat your back. You didn't get it? Slap yourself. Make sure you write the statements exactly the way I write. I mean, not in such a horrible handwriting. Write very neatly. I'm writing very fast. Time is short. See, alternate angles, we have to mention AB parallel to FE whenever we use such properties. I don't care how you used to solve in lower standards. This is the correct way. It's my way or the highway. And please don't go to the highway.